In Module 8 on compensating wage differentials, I've set up a problem in the review problem for which you'll need to understand how to use a quadratic equation. Many of you remember this equation and its in its form from your algebra courses, but some of us don't, and so I thought I'd take a few minutes and go through how to work this equation and how to work that particular review problem out. So this might be helpful for some of you. The problem in review problem 1 tells us that we are looking for compensating wage differential form. We've been talking about the use of ISO profit and ISO benefit curves. And I've given you two equations. W is equal to 36.25 plus 0.25R squared. And then R is equal to 1/5 W minus 1. And you'll know that at some point you're going to want to equilibrate those or set them equal to each other. And when we do so, we then are going to try to solve for R or W. So let's think about how we might do this. First, I can't immediately see how to set these equations equal to each other. This is different than LS is equal to LD. But maybe I can go ahead and rearrange one of these equations so that I end up with W equals something and then W equals something else. And then I can have an equilibrating equation that has with one variable. So let's see if we can't do that. I'm going to go ahead and rearrange R equals 1/5 W minus 1. So if that's true, then I can also say the 1/5 W equals R plus 1, or W equals 5R plus 5. Plus 5. And I can go ahead then and substitute this value of W into this equation, or that's another way of saying I can set them equal to each other. If W equals W, which it clearly does, then 36.25 plus 0.2R squared equals 5R plus 5. So let's look at that. 5R plus 5 equals 36.25 plus 0.2R squared. Well, you'll immediately recognize you're going to end up with a quadratic equation here. And if you don't immediately recognize that, you should get to the point where you can. We've got a constant. We have a scalar in front of the R variable to the power of 1, and then we have a scalar in front of the R variable to the power of 2 or squared. That is going to yield a quadratic form. And in the quadratic form, it's much easier if we end up with a positive squared variable. So let's go ahead and rearrange this so that we end up with 0 equals something, so we can use the quadratic form for that. So I think this is going to yield 0 equals 36.25 minus 5R minus 5 plus 0.2R squared. If I simplify and rearrange that so that I have my squared variable at the beginning and then my scaled variable and then my constant, it'll help me fit it into this quadratic form a little easier. So let's do that. So I'm going to say that this is equal to 0.2R squared minus 5R plus 31.25. Well, you might recall in the quadratic form that we're looking for some A and B and C. And A is the scalar in front of the squared variable. B is the scalar in front of the variable to the power of 1, and C is the constant. So that's good. So I've gone ahead and set that up for myself, and I can now go ahead and put this into the quadratic form. Recall that the quadratic equation that allows us to solve for a variable is going to be minus b plus or minus the square root of b squared minus 4 times A times C, all divided by 2A. And that's going to equal the variable. Or in this case, it's going to equal R star, or the equilibrium value of R. Well, you might realize then in looking at this equation, we may have two different outcomes, because we're going to solve this equation first by saying negative b plus the square root of b squared minus 4ac, all divided by 2a, and that's going to give us an outcome. But then we're going to run it again saying negative b minus b squared, or square root of b squared minus 4ac, all divided by 2a. So we have two potential outcomes here, and we're going to have to think about these. Typically in economics, when you have this, or maybe it's just not economics, typically you have these two outcomes, one of them will be obviously irrelevant, completely implausible. The other one might work. So let's go ahead and see how this sets up, and if we can go ahead and solve this equation. So again, we had R being equal to 0.2 R squared minus 5R plus 31.25, and that was our A, B, and C. So let's go ahead and put that into that quadratic equation such that we've got R is equal to negative 5, and that's the negative of negative 5 because it's negative B, right? Let me set that up a little differently. So negative 5 plus or minus 5 squared minus 4 times 0.2, that's A, times 31.25, which is C. And then all of that over 2 times A, or 0.2. Okay, so let's keep going here. So that's going to equal then 5, because the negative of negative 5 is 5, plus or minus 25, so 5 squared is 25, minus 4 times 0.2 times 31.25. Well, if you take out your calculator very quickly, 4 times 0.2 times 31.25 is equal to 25, divided by 0.4, or 2 times 0.2. Well, I've set this up for you so that the irrelevant, we don't even have to think about the possibly irrelevant outcome, because 5 plus the square root of 25 minus 25, well, 25 minus 25 is 0. The square root of 0 is 0. So we really simply have 5 divided by 0.4, which is equal to 12.5. And that's going to equal R star. And now that we know that, we can go ahead and put that value of R into either of these equations, because we know that they are the same at some point. I'm going to prefer to put them into this equation, W equals 5R plus 5. Not only is it solving for W, which is what I want, W star, but it's just a lot easier than putting it into W equals 36.25 plus 0.2R squared, in which case we have to do a little bit more calculating. So let's just put this into W equals 5R plus 5. So W equals 5 times 12.5 plus 5. And 5 times 12.5 is equal to 62.5, plus 5 is equal to 67.5, which is equal to W star. So we now know that our equilibrium values of R and W are 12.5 and 67.5 respectively. If you think about what that's going to look like in a graphic form in wage and risk space, we have wage at 67.5 and R starred or risk, the equilibrium level at 12.5. And we know from the expected shape of these curves that the wage curve in this space is going to be, or rather the indifference curve in this space is going to be upward sloping and convex, and that the isoprofit curve is going to end up giving us some kind of a upward sloping and possibly concave or quasi-concave form. Well, I hope this has helped a little bit.